So on 42, on that one, the wavelengths, you should have 3 wavelengths, ranging from about 200 to about 600.
Wait, hold on.
Hold on.
Wait, what are 2? 3? What are 2?
They can go from 4 to 0, from 6 to 0, and from 6 to 0.
What do you mean wavelengths?
What do you mean? Wait, how much?
I did electronics.
Wait.
Also, I know like your thing is like because 41 also had an energy diagram. But
So many tips.
Okay. So on 45, so let's talk about 45. So you got the speed of an electron is known to be between 3 times 10 to the 6 and 3.2 times 10 to the 6.
Do you understand why?
So this is the Heisenberg uncertainty principle. Now, here's kind of the unspoken part of this question on 45. It gives uncertainty in the velocity. But by having uncertainty in the velocity, what other physical quantity then do you have uncertainty in? Momentum. Okay? You also have uncertainty in the momentum, because momentum is mass times velocity. So your answer to 45 should be a really small number. What?
What's like the equation we need to use?
Delta X delta P equals H over 4.
Yeah.
So it's delta x times delta p.
Yeah, so it's delta x, delta p.
Wait, so we're finding the how are we finding the position? We can't find the position.
Well, that's actually the whole idea, is that you can't find the position.
Uncertainty.
That's the
It's not an equal sign, it's actually greater than a shadow.
but you treat it as an equal sign.
Yeah, check.
Why would we?
Oh.
Really know.
On 54, which is this photoelectric effect, there's a couple of ways you can do 54. It's whatever you want to do. So here's the whole point of the graph, is that you have V stop here, and then you have
Oh,
frequency
my calculator's got it back.
times 10 to the 15th hertz. Alright? Now, God, it's weird. This thing just randomly jumps in.
Yeah, I was
It's
looking at
between
the
like all of the block. I would look up and it was just like
What is
You are,
Okay.
you are a billion off. More than a billion.
Maybe this goes
You are 10 to the 12th off. Wait, no, 10 to the 20th off.
I think I'm a trillion.
No, you're 10 to the 20th off.
That is like one.
The answer is 10 to the negative 10, and you got 10 to the negative. You got 10 to the 10th.
Okay.
Oh my god. Wait, you said the answer 10 to the 10. Negative 10?
Yeah, that's right.
So on 54, let's talk about this graph. Let's just randomly jump again. So, what is this x-axis indicating?
Frequency times 10 to the 15.
Oh.
I got that part. But what is it telling you? Energy of what?
The photons.
Energy of the photon?
What?
Energy of the photon or the energy of the emitted electron?
Both. Photon.
What?
We're talking about energy is photon, no?
This just gives you the energy of the incoming photon.
Find out here.
Right? So, God, it's just weird. That line just jumped. So, now it just completely disappeared. Weird. Okay. Let me just try this again. Now I can't even erase.
The jumps
Kano is eating.
Okay, I have no idea what's going on. You have the graph. Here's some things that you need to know.
All my numbers.
Why is there a horizontal line at the beginning,
Threshold frequency.
right here, where there's nothing happening.
Threshold.
Of what?
Frequency.
It
Shouldn't
doesn't
it be
have
what?
to-
Activate
electron.
Okay, so this would be like me showing up and I don't have enough money to get Nathan out of jail.
Nothing happened.
Okay? So remember, this x-axis here is a reflection of the energy of the incoming photon. Okay?
Shannon, we're both on this.
Why is this a linear function afterwards? What one equation tells you is this is a linear function.
2.9 negative.
Huh?
So that,
I don't care what the back of the book says, Dad.
it says 5.8.
So this is a linear function because E equals, I can't write right now.
I believe you.
Hold on.
Shannon, that
Let
book
me
says nothing
get
what you
to
said.
what
Hang on, we try to leave you.
Oh, so one of them is the same.
Bro, I thought Trump said that your thing was done, Bird.
Oh, yeah.
I haven't done 50.
Hey, what do you guys doing? 51?
51?
What'd you get on 45? What'd you get on 45?
1 e to
You
the
see
6.
45. Can you see
And
45?
then 4.3.
What? He got 15. He got to the 15.
Wow.
I got 10.
I got
Big
that.
Mike, what'd you get?
I got
I got 10 too.
Yeah, it's just, yeah.
What was your first number on 45?
Okay, let's try this
What the
again.
freak?
Oh.
Don't you use the master electron?
So let's go back to 54. Now that mine's been drawn.
You have been promoted.
So here's the setup. You've got this graph, you have a horizontal line, this is your frequency, this is your stop. So on 54, you want to find the work function in electron volts. Okay? So what you want to do is use K max equals HF minus your work function. So what I would recommend is that you come out here and you pick a point that's on the line.
Yes, I did.
Okay? Pick a point that's on the line. So your V stop is, because that's in voltage, that is your electron volts. That is the number. You don't have to do anything weird with it. So then you're going to know that number. Whatever frequency corresponds with that allows you to get your HF. And then from that, you can find your work function. So your work function on number 54 is around 4.
Yeah.
Like a good GPA.
A really good GPA.
Yo, Bird, we need to go over a scientific meeting. Buddy, what is this? Michael.
Hey,
It's not that difficult.
It's about the. Are you fine with 10.8 times 10 to the 5th? Or do you want like?
Why would you write it like
On
that?
what?
On like 51C.
Girl, why would you write it like that? You always do single digits.
You want?
It's one number to the left.
Well, what's wrong if I do 10.8?
Because I'm getting annoyed. That's why.
Yeah, my bad.
Like 380.
What about 44? Like if I write 44, yeah, 44.
step.
Okay,
I'm giving 0 numbers.
are we good?
Yeah, but we're good.
Going once, going twice.
Oh, 2.4.
So,
What did you get on the 30?
Oh, actually, I'm so sorry.
D-D-D-D-A-A.
The math was on number 31, question 31.
This is
The back of the book says B.
Oh, I had them back.
I'm talking about like different
frequency is
frequencies.
up.
So how does
So
that
you both know it'll get faster.
photons per second?
So Adam's
And then
leaving.
34
will be
hold on,
fast.
just, which one?
31.
Any questions on
Adam's
one?
Yeah.
electrons will have to jump. 'Cause-
Okay, the same power output.
So,
Okay,
so
so
if you
power
have
is a
to
measure of
the
what?
energy going into the atom,
I
you'll
get
be
it.
able to jump.
Intensity over area.
Yeah.
Dude, I asked him what he meant by
This
I
increases
don't know, I just
more
wrote down
and more
that.
energy gets reached.
Is it?
So Adam's jumping.
Can you explain 34? Maybe you should ask Bird, can you explain
So they are.
So it's just kind of a ratio. So you know E equals
That's pretty
HF.
much it. Because it takes
Right?
takes
So if you have,
long
this will line up with 500
energy
nanometers.
reaching the atom.
So you can find
takes
the
like a half a
energy in that.
Or whatever. This is
Now, the
So
problem
this
is
would
you
get
have
you
different
huge
units.
amounts.
So then you have a radio wave has a wavelength of 1 meter.
Constantly.
So here, you've got to pick about, you want to convert nanometers into
And
meters,
this, since this is also.
and then use AC over lambda. That's just the battle that you have to choose. You would convert the 1 meter into nanometers, and then you use 1242 over that. It's just a matter of finding that different balance. Okay? All right, so I'm going to do a little bit of reading
It's bad.
from this book called Alice in Quantum Land.
Wait, no homework. Good news, bad news day.
But
there's homework.
it's one of the shorter assignments I've given you for a while. Okay? I know, it's not
Wait, Bird, real quick, off subject, speaking of books, do you know the Urkalanis?
Huh?
Do you know the Urkalanis?
No,
You know the last name?
no. Should I?
They say they know you. It's my aunt. That's cool. They said they used to go to church with you.
Everybody knows this guy.
Not anymore.
It's Laverne.
Okay, so I'm gonna read this over a series of days. This is just to kind of get it started. Okay? So, if you've seen or heard the book Alice in
Wonderland.
Wow. So this is Alice in Wonderland. So does anybody know if you've read Alice in Wonderland, there's a guy in there called the Mad Hatter. Anybody know the origin of the Mad Hatter?
Yes, that
No.
Like really?
So the reason they called him the Mad Hatter is like, and that was the saying, you're crazier than a Mad Hatter. So what happened is that they used to do
I was just over here for the
of
will.
these fell cats. They would use mercury compound to make them water resistant. What they didn't know was that mercury compound is very toxic, and they would inhale that, and it would make them go crazy. And so if you said you were crazier than a Mad Hatter, that's where that came from. So they figured out that the mercury worked phenomenally well, but if you're constantly exposed to it, it would cause neurological damage, and you would go crazy. So the Mad Hatter in Alice in Wonderland has a chemistry basis from that. So here's the story on this one. And this is the beauty of like knowledge of science or whatever. You can read stories like this and go, oh, I know exactly what they're talking about. So just kind of chill out. Let me do a little bit of reading. So, Alice was bored. All her friends were on holiday or visiting relatives, and it was raining. So she was marooned indoors watching television. So for that afternoon, she watched part of a 5-part series of an introductory on gardening and a paid political broadcast. But at the end of the day, she was pretty bored. She stared in frustration at the screen, which at that moment carried the picture of the Prime Minister telling her how, all things considered, everything was really far better off than it had been 3 years ago, even if it didn't always seem that way. As she watched, she was mildly surprised to see the picture of the Prime Minister's face slowly break apart into a mist of bright dancing speckles, which all seemed to be rushing inward, as if beckoning her. Why, said Alice, I do believe they want me to follow them in. She leapt to her feet and started down towards the television, but tripped on the book which she had discarded so untidily on the floor and fell headlong. As she fell forward, she was amazed to see the screen grow enormously, as she found herself in among the swirling speckles, rushing with them down into the picture. I cannot see anything with these dots swirling all around me, thought Alice. It is just like being lost in a snowstorm, but I cannot even see my feet. I wish I could see just a little. I could be anywhere. At that moment, Alice felt her feet strike something solid, and she found herself standing on a hard, flat surface. All around her, the swirling dots were fading away, and she found that she was surrounded by a number of vague shapes. She looked more closely at the one nearest to her and observed a small figure coming roughly up to her waist. It was exceedingly difficult to make out, as all the time it kept hopping rapidly to and fro, moving so fast that it was very difficult to see all clearly. The figure seemed to be carrying some sort of a stick, or possibly a rolled umbrella, which was pointing straight up in the air. Hello, Alice introduced herself politely. I am Alice. May I ask who you are? I am an electron, said the figure. I am a spin-up electron. You can readily tell me apart from my friend there who is a spin-down electron. So, of course, she is quite different. Under his breath, he added something which sounded rather like "Viva la différence." As far as Alice could see, the other electron looked very much the same, except that her umbrella, or whatever it was pointing down toward the ground. It was very difficult to tell for sure, as this figure was also jiggling to and fro as rapidly as the first. "Oh, please," said Alice to her first acquaintance, "would you be good enough to stand still for a moment, as I really cannot see you at all clearly." "I am good enough," said the electron, "but I'm afraid there is not room enough. However, I will try." So saying, he slowed his rate of jiggling down. But as he moved more slowly, he began to expand sideways and become more and more diffuse. Now, although he was no longer moving at all quickly, he looked so fuzzy and quite out of focus that Alice could no more see what he looked like than she had been able to see before. "That is the best I can do," he panted. "I'm afraid that the more slowly I move, the more spread out I become. This is the way things are here in quantum land. The smaller the space that you occupy, the faster you have to move. It's one of the rules, and there's nothing I can do about it." "There really isn't room enough to slow down here," continued Alice's companion as he began once more to leap rapidly around. "The platform is becoming so crowded that I have to be more compact." Sure enough, the space in which Alice stood had now become very crowded indeed, being closely packed with small figures, each dancing feverishly to and fro. "What strange things," thought Alice. "I do not think I shall ever be able to quite be sure what they look like if they will not stand still for a minute, and there does not even seem to be much chance of that." Since it did not look as if she could slow them down, she tried another topic. "Would you please tell me what sort of platform we are on?" she asked. "Why, a railway platform, of course," replied one of the electrons. It was very hard for Alice to say which one had spoken. They really did all very much look the same. "We are going to take the waves train to the screen, you see. You will change there to the Photon Express, I expect, if you want to go any further." "You mean the television screen?" asked Alice. "Why, of course I do," cried one of the electrons. Alice could have sworn that it was not the same one which she had just spoken to, but it was very difficult to be certain. "Come on, the train is here and we have to get on." Sure enough, Alice could see a line of small compartments drawn up on the platform. They were very small, some were empty, some had one electron, some had two. All of the empty compartments were filling rapidly. In fact, there did not seem to be any left. But Alice noticed that not one of the compartments held more than two electrons. As they passed by one of these compartments, the two occupants would cry out, "No room, no room!" Surely you could squeeze more than two in a compartment, seeing as the train is so crowded, Alice asked her companion. "Oh no, never more than two electrons. That is the rule." "I suppose we shall have to get into different compartments then," declared Alice regretfully. But the electron reassured her. "There's no problem there for you, no problem at all. You can get into any compartment that you want." "I'm sure that I do not see why that should be," Alice replied. "If a compartment is too full to hold you, then it must be surely be too full to hold me." "Not at all. The compartments are only allowed to hold two electrons, so almost all the space for electrons may be taken up. But you are not an electron. There is not a single other Alice on the train, so there is plenty of room for an Alice in any of the compartments." This did not seem to follow for Alice as far as she could see, but she was so afraid that the train would start to move before she got her seat, so she began looking for an empty space that could take another electron. "How about this one?" she asked her associate. "Here's a compartment with only one other electron already in it. Can you get him?" "Oh, certainly not," he snapped, sounding quite horrified. "That is another spin-up electron. I cannot share a compartment with another spin-up electron. What a suggestion. It is quite against my principle." "Don't you mean against your principles?" Alice asked. "I mean what I say. Against my principle, or rather Pauli's principle. It forbids any two of us electrons from doing the exact same thing, which includes being in the same space and having the same spin," he responded crossly. Alice did not really know why she had it set in, but she looked around hastily to find another compartment which might suit him better. She managed to find one that held a single electron who was of the spin down variety, and Alice's companion leaped into this one readily enough. I was surprised to find out that although the tiny compartment now seemed full, there was somehow enough room for her to fit in quite easily. No sooner were they settled than the train was off. The journey was uneventful and the scenery not very interesting. So Alice was rather glad when the train began to slow down. This must be the screen, I suppose, thought Alice. I wonder what will happen here. As they lighted on the screen, there was an enormous bustle everywhere. Where is everyone going? Alice wondered aloud. Why does everyone seem to be so excited? Her questions were answered by an announcement which appeared to come from the air around her. The screen phosphor is presently being excited by the incoming electrons, and we shall all be having photon emissions soon. Stand by for the departure of the Photon Express. Alice looked around to see if she could see the express arriving, when there was a rush of shining lights shining past her across the platform. Alice was caught up in the middle of the crowd and carried along with them as they crowded into one compartment. Well, they do not seem to be worried by any principle, Polly or otherwise, thought Alice as the crowd had been around her. These ones are certainly not worried about all being in the same place. I suppose the express is about to start soon. I wonder where we shall end up. She concluded as she stepped out onto the platform. My, that was certainly a fast journey. Why, it seemed not to take any time at all. Alice was quite right about this. The journey did indeed take no time at all, as time is effectively frozen for anything which is traveling at the velocity of light. Once again, she found herself surrounded by a crowd of electrons all rushing away from the platform. Come along, one of them cried, as to rush her off. We must get out of the station now if we have to get anywhere. Excuse me, Alice said tentatively. Are you the same electron that I was talking to before? Yes, I am, answered the electron as it darted off down a side passage. Alice was left alone by the platform of electrons that carried through the main gateway from the platform. I declare this is really too irksome. That's a good word, irksome. Now I have lost the only person I know at all in this strange place, and I have no one to explain what has happened.
Berg, what does irksome mean?
Irritating.
Irritating.
Like, there are times you would be
There's a reason why he did that.
Okay, that's what I
Michael's
thought.
quite irksome.
Yeah, quite irksome at times.
Yeah, because Shaq's in here.
Huh?
What?
Have you ever read the Phantom Troll Booth?
Huh?
Have you ever read the Phantom Troll Booth?
Never.
Would that book be like considered literary merit for the AP class?
You know,
Alice in Quantumland? No.
Yeah, could I use that for my key period?
That I don't know. I think you could.
you're not reading that in 2 days.
We were using that for 2 or 3. Ryan, I haven't read half the books for AP.
Yeah, this guy read Jurassic Park in a week in a day.
Okay, I actually did. I actually
Okay,
did read that.
so you all have the test on Wednesday and Thursday, of course, those of you that are taking it. So I want to spend the last 2 days kind of wrapping up all this quantum stuff. So today is kind of like a hodgepodge of stuff. Some of it is just general knowledge. And the assignment tonight won't be bad at all. We've got, which is like over chapter 29. And then chapter 30 is kind of the big one on radioactive decay, which we'll cover tomorrow. And that's a big assignment. But it's just kind of become the tradition on that last assignment out of chapter 30. I'm just going to run off the answer key and give you the answer to chapter 30. Okay? So tonight I will give you the last assignment that you will actually have to hand in for the class.
Oh my gosh, Berg, we're almost there.
So don't forget the test over all this stuff is going to be on Tuesday, not Friday. And then I want to spend Monday and Tuesday watching Apollo 13 and really doing a deep dive into like the mechanics of it, because now you all understand so much about what's happening in that movie. So we're going to spend a lot of time talking through that. So,
What happened to going to San Francisco?
huh?
What happened to going to San Francisco?
Well, it's just been so cloudy.
It's a beautiful day out.
Is it really? Okay,
We should watch another show.
let's go out and look at some.
Yeah.
We're gonna get, no, we're gonna get just a sample one. So, stop